Hey everyone, Roland this side. I hope you all are doing well. So let's say the problem of the day.
So the problem here is 2130 maximum twin sum of a linked list. So we have to find the maximum twin sum from a linked list. So what is a twin sum? Okay. So first of all, let's understand what is a twin. Okay. So we are given a linked list like this. 4, 5, 6. Okay. So at A, so what is the twin of A? The twin of first item is gonna be the last, okay, A dash. The twin of second is gonna be second last. The twin of third is gonna be third last, okay. And similarly, so what we have to return, we have to, for index twin is n minus y minus ith node. For example, we have to return the twin sums, okay. So what basically for this twin, the sum is A plus A dash. So we have to basically represent the and linked list for any ith twin I comma I dash. We have to represent the we have to return the maximum of linked list. Okay. So what we are basically gonna do is, so the first and the most brute force one what you wanna think is, first of all, let's suppose we have a linked list like something like this. 1, 2, 3, 4, 5, 6. Okay, or in question here given is number of nodes equal to number of nodes is always even. Okay, so suppose we have linked list. So what we are going to do, we are going to initialize a vector of same size. We are going to initialize a vector of int type. Let's call it copy. And what we are going to do is we are going to copy the linked list into vector. For example, you can do is while while head is not null, we can just do head of value, copy dot push back the value of head, and the head equal to next of head. Okay, next of head, like that. So it's gonna convert our linked list into an array. So now 1, 2, 3, 4, 5. Now we got 1, 2, 3, 4, 5, 6. Okay, so now what we can do is, for I equal to 0, I less than copy dot size by 2 and I plus plus. Now what we are going to do is, I mean, suppose this is our result, int result. So what we are going to do is result equal to maximum of, let's consider first sum. So what is the twin sum here? Twin sum gonna become copy of I plus copy of copy dot size minus 1 minus I. Okay, so we have to store that in result the maximum of result and twin sum. So that's how we are going to get the twin sum and the maximum. So if you see here, the time complexity is big of n. We are iterating to big of 2n, so that's as similar to big of n, and the space complexity also gonna become big of n. Okay, so we are iterating once here. So interviewer is not might be happy here. So what we are going to, how can reduce this to, how we can reduce the space complexity to big of 1. Okay, so for that what we are going to do is, so okay, so suppose we have this linked list. So what we are going to do is we are going to use this fast and slow approach to find the mid one. So what we are basically going to do is, suppose we have a pointer called fast here, and a slow here. So what we are going to, you are going to do the fast next. So fast gonna jump to here. So this become fast, and we are going to do the slow next. So slow gonna become here. Okay. So again do the fast next. So fast gonna return here, and slow gonna return here. Okay. And neither fast is we are going to do either fast next is empty or fast is null. Okay, fast null and fast next both shouldn't be null. Okay, so I mean to do one more time till fast next not equal to null. Okay, yeah, like that. Fast next should not equal to null, and fast also should not equal to null. So after doing one more time, here null, slow gonna lead here, so it's slow at 4. So we are first using the slow and fast method. So the code of slow and fast is, I mean, simple as that. Like, I mean, list node slow equal to add list node fast equal to head. Okay, and while fast and fast next not equal to null, we are going to do as slow equal to slow next and fast equal to fast next. Okay, so that's the total code to move to get this slow and fast. And after getting this slow, we are going to reverse that. I mean, reverse that second half of the array. Okay, so this is the second half where slow is starting, and this is the first half. So we are going to reverse the second half. Okay, so we get something like, I mean, let's consider a pointer of list node called previous. Okay, so what we are going to do is, while I mean, for example, add another list node called current that is equal to slow. So while current is not null, what we are going to do is get the next, I mean left next node. So after getting the next node, I mean what is the next node? Current dot next, and after that, I mean wait a second. And after that, what we are going to do is current. We are going to switch the, I mean reverse that current next gonna become previous. Okay, and then restore, then move the previous to current and move the current to pre next. Okay, so that's the total current. So what it gonna do is, for example, we have linked list 1 2 3 4 5 6. So what it gonna do is, while so current is at slow, so current is here, and so next gonna become, this one is next. So the current, I mean next pointer to current, so it gonna point to previous. Okay, and what previous is hold on, yeah, previous is null here actually. For example, we initialize previous as null pointer. So this is the current, so and previous is null, so it gonna point to null 4. Okay, so remove the 4, it gonna point to a null. Yeah, and after that previous become current, I mean, and current become next. Okay, so this become previous, this become current, and after that what we are going to do, and again do the next is here. So again reverse the current next equal to previous, so current next gonna become previous. So this, and again move these 3. Here is it gonna become previous, it gonna become current, and next gonna become a null pointer. Okay, so next is a null pointer. Then next is, we got next as null pointer and switch current to previous. and move current to null pointer. Here we got previous, here we got current to null. Okay, so we got current, so we're gonna exit the loop. So now we got two pointers where previous, we have this as head, we have this address at head, and now we got 654, and this address is previous. Okay, so what we can do, we can see if we got this in, twin pair. Okay, 1 and 6 is twin pair, 2 and 5 is twin pair, 3 and 4 is twin pair. We basically I mean took this up and flip it like this. Okay, so it's become this. That's how I flip it. And so this gonna be equal to this, and this gonna equal to this. So it's basically similar to like that. So, okay, so what we are going to do is, I mean we got the two halves. So what we are going to do, I mean we can take list node p1 equal to head, and list node p2 equal to previous. We got previous as our previous is the pointer of second list node. So we are going to do is while any of them is null, we have to, so we have to do the result equal to maximum of result comma p1 value plus p2 value. Okay, and keep moving the p1 next, p2 equal to p2 next. Okay, so that's the total code, I think so. Yeah, it is. And at last just return the result. After getting this, second pointer at second half, we are going to break it and reverse it, get the pointer at 6. And after reversing it and getting a pointer at 6, we are calculating the, we are iterating both simultaneously and getting the maximum. So the time complexity here is, this requires big O of n, and while current is current next, so current is here, so it requires big O of n by 2, and here it again requires big O of n by 2. Okay, so in total time complexity equal to big O of n plus n by 2 plus n by 2, that is big O of 2n, which is as good as big O of n, and space complexity is also big O of 1. So I think we optimize here, so let's code it. So okay, so first what we have to do, we have to do the slow first to find the mid, and then reverse it, and then find the result. Okay, so let's get the slow first. List node slow equal to head, list node first equal to head, while first and first next is not equal to null. What we are going to do is slow equal to next equal to next, first equal to next of first, and one more next. And now slow gonna return the middle. So after getting the middle, we are going to do is list node previous equal to null pointer, and list node what current gonna become slow. Okay, and while current is not null, what we are going to do is first get the next list node next equal to next of current. Now reverse it. So current next gonna equal previous, and now pass current to, pass previous to current, and then pass current to next. Okay, and after, from here what we are going to get is list node p1 equal to head, list node, yeah, pointer p2 equal to previous, and after that what we are going to do is, while p1 is not null, we are going to get the result equal to maximum of result, and p1 value, plus p2 value, and at last we are going to, okay, we enter as equal to 0. At last we have to return the result. So if we run the code out, I think TLE, we got TLE. Okay, we forgot to do P1 next. P1 next and P2 equal to P2 next. So I think it should be fine now. Wait, okay. So we wrote P2 because P1 it started from head, so it gonna continue till last. Okay, so that's why we have to do P2. For example, here this head pointer still contains something. It is still connected to 4. Okay, because 4 is connected to, but it is still connected to 4. So we got an extra, exceed limit. So here we are at fourth pointer, and his fourth pointer does not exist. Okay, so that's why we got an, boundary limits. So that's total code where time complexity and space complexity is big of, and space complexity is constant. We are not using any extra space, and time complexity is big of. And okay, so if we submit the code, it should pass all test cases. Yeah, it will. So I think that's it for today. I hope you like this video. So please make sure to subscribe to Tensor, and feel free to ask any doubts if you have in comments. Till then, keep smiling and keep coding.